Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 10 maths algebra, exponents, and part 1. Before we look at exponents, we need to look at the laws of exponents that we learned in previous grades. For example, x to the m times x to the n is equal to x to the m plus n. So if you're multiplying and you have common bases, remember you add the indices. And an example of that would be if I had 2 squared times 2 cubed, that will equal 2 to the 2 plus 3, which is equal to 2 to the 5. X to the m divided by x to the n equals to x to the m minus n. So if I'm dividing and have common bases, I need to subtract the indices. An example of that, if I had 2 to the 5 divided by 2 squared, that will equal to 2 to the 5 minus 2, which is 2 cubed. Here, if I have an index which is raised to a power or vice versa, power raised to an index, I need to multiply. So that will be x to the m times n. So if we have 2 squared all cubed, that will be 2 to the 2 times 3, which is 2 to the 6. And here if I have x to the m times y to the m, it's equal to xy to the m. An example of that is if I had 2 times 3 all squared, that will be 2 squared times 3 squared. Here the law for negative indices, x to the minus n is 1 over x to the n, and the law for zero exponents, x to the 0 equals to 1, where x is not equal to 0. So it's important for us to know that 2 to the minus 1 is equal to 1 over 2, and similarly 2 to the 0 will equals to 1. So these are the laws of exponents that we must know. Let's go look at a question. Now the first question that we're looking at is from the DBE November 2018 paper 1. I call this a type 1 example because it only involves multiplication and division of exponents. So the first step here would be to write everything as prime bases. What is a prime base? Prime base is a prime number. The smallest prime number is 2, then comes 3, 5, 7, and so on. So we need to write our bases as prime numbers. Like for example, 25 is 5 squared. 5 squared. 25 equals to 5 squared. 15 is going to equals to 3 times 5, and so on. Right? 3 and 5 are already prime bases. So let's write that down. 5 squared minus x times 3 times 5 to x plus 1 all over 3 to the x times 5 to the minus x, which is equal to, now we're going to apply that law that we discussed earlier. When we have an index raised to a power, we need to multiply. So that's 5 to the 2 times minus x is minus 2x times 3 times 5 to the x plus 1. Also the law that we discussed a little bit earlier. We're going to get 3 to the x plus 1 times 5 to the x plus 1. Remember there's a 1 there, right? So 1 times x is x, 1 times 1 is 1. There's also 1 there, 1 times x is x, and 1 times 1 is 1. And here we got 3 to the x times 5 to the minus x. So we've written down our prime bases, and now what's left for us to do is to apply these rules that if we have common bases and we multiply, we add the indices. If we have common bases and we divide, we subtract the indices. So what you notice, we've got base 5 all over here. Base 5, base 5, and base 5. So let's deal with that. So if I look at that now, I'm going to get 5 minus 2x. Now I'm adding the indices because why I'm multiplying, right? So it's going to be plus x plus 1. But if you notice here in the bottom, remember I'm dividing now. So therefore, I'm going to subtract. So that's going to be minus x, which is going to become plus x. So you can just remember it by just change the sign of the bottom exponents. Times. So let's look at the next one. We've got 3, base 3 there, and base 3. So that will be 3 to the x plus 1 So here, because we're dividing, we need to say we're subtracting the x now, right? So it's minus x. So we just change the sign once again. Minus x. Simplifying, we're going to be left with 5 minus 2x plus x plus x. So that's minus 2x plus 2x is 0. So they all cancel here, which leaves me with 5 to the 1 times plus x and minus x is 0. So I'm left with 3 to the power 1 there. So my answer is going to be 5 to the 1, which is 5 times 3 to the 1 is 3. 5 times 3 is 15. That's my solution. 15. So that's a type 1 example, and you can see that we're applying these laws of exponents that I went over in the first part of the video. Let's look at another example. The question that I'm now going to be looking at is from the DBE November 2015 paper 1. Once again, here I've got 10, so I've got to write that as a prime base. So let's see, 10 equals to 2 times 5. Remember, 2 and 5 are prime numbers. 4 equals to 2 squared, and 25 is 5 squared. So if we can now do that, we'll get 2 times 5 to the 2x plus 3 times 2 squared to the 1 minus x all over 5 squared to the 2 plus x. So remember, 10 is 2 times 5 to the 2x plus 3. 4 is 2 squared to the 1 minus x. And 25 is 5 squared to the 2 plus x. Let's open the brackets according to those laws that we discussed earlier. Remember, there's a 1 here, 1 times 2x plus 3, so that'll be 2 to the 2x plus 3 times 5. Remember, there's a 1 there as well. 1 times 2x plus 3 is going to be 2x plus 3 times 2. Remember, 2 times 1 is 2, and 2 times minus x is minus 2x. 2 times 1 is 2, 2 times minus x minus 2x. All over 5. And here you got 2 times 2 is 4. And then 2 times plus x is plus 2x plus 2x. So now we've opened the brackets according to rules where you got a power raised to an index or index raised to a power. You have to multiply. So let's look at our common bases here. Right, what do we have? So our common bases will be as follows: 2 and 2. So there is just multiplication, so I'm going to add the bases, or add the indices I should say. 2, so it's going to be 2x plus 3, and it's going to be plus 2 minus 2x. So I'm just adding 2x plus 3 plus 2 minus 2x. Here, I've got 5, base 5 and base 5, right? But don't forget now, I'm dividing, so I'm going to subtract the indices. So that's going to be times 5, 2x plus 3, 2x plus 3. Because I'm subtracting the indices, I'm just going to change the signs down here. So that's going to be minus 4 and minus 2x. So now let's simplify. So what am I left with? 2x minus 2x cancel, so I'm left with 2 to the 3 plus 2, which is 5. So 2 to the 5. And here, 2x minus 2x is 0, so I'm left with 3 minus 4 is minus 1, so that's 5 to the minus 1. So let's simplify. Remember the law for negative exponents. We're going to be left with 2 to the 5 all over 5 to the 1. Okay, and 2 to the 5 is? 2 to the 5 is 32. 32 all over 5. That is, if you haven't subscribed already, subscribe to JL Maths YouTube channel. You can also like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.